lesson, we are going to learn how to develop the first principle, a formula that is used to determine the slope of a tangent line. As you can see, there is a function fx given on the graph, and there is a point P on the graph, and point P is where we need to draw the tangent line. When you draw the tangent line, you need to make sure the line only touches the curve once and going through point P. In order to find the slope of the tangent line, which is a pink line, we need to know 2 points that are on the pink line. However, we only know 1 point, which is P. Therefore, we need to approximate the slope of the tangent line by using the slope of a secant line. The secant line is a line segment between 2 points that are on the curve. Now, let's try to find a second point that is on fx. Let's call it q prime. And we're going to connect point P and q prime together to make a secant line. As you can see, the slope of the pink line and the slope of the green line are definitely not the same. So therefore, that means we have to pick a different second point. Let's call it q double prime. Now we connect point P and q double prime together to make another secant line. As you can see, the slope of the blue line is even more off than the slope of the pink line than the green one. This tells us when we choose a second point that is on the curve, we're supposed to choose a point that is closer to P, not further away from point P. So now let's try to pick a different one. So let's call it q triple prime. This time we're going to choose a point that's closer to point P now. And we draw a line segment. As you can see, this red line, the slope of the red line is definitely closer to the slope of the pink line. However, those two lines are still not having the same slope. That means we need to choose a better point. So this time, we're going to choose a point that is extremely close to P and right beside P. So we're going to choose a point that is right beside P, which is called Q. And we're going to draw a line segment between P and Q. And you can see this line segment is almost identical as the pink line. That means they are having the same slope or approximately the same slope. So now let's develop the formula. As we learned before, slope equals to y2 minus y1 over x2 minus x1. The difference in y over the difference in x. So slope equals to y2 can be written as f of x2, y1 can be written as f of x1 over x2 minus x1. The coordinates of the P is called x1 and y1. The coordinates of the Q is x2 and y2. Now, let's say the difference between x1 and x2 is h. Then I can write x2 equals to x1 plus h. Then I can modify the equation to be m equals to f of x1 plus h minus f of x1 over x1 plus h minus x1. Now we can further simplify this formula by collecting the like term in the denominator. This formula is used to find slope of secant between any 2 points on the curve. This implies the difference between the two x values, h, it does not have to be very small because we are finding slope of a secant line. In order to find the slope of a tangent at point P, that means we want to choose a second point that is extremely close to point P. That means the h, the difference between the two x values, must be very small. Therefore, we write slope equals to limit. That means we put the restriction on what the value h can be. So h is approaching to 0. That means h is an extremely small number. That means the difference between the x values are very small. That means we're finding slope of a tangent at point P. F of x1 plus h minus f of x1 divided by h. And this is slope of a tangent line. H is extremely small. This is a slope of a tangent line. Therefore, we say this is actually called the first principles. So the first principles is a formula to find the slope of a tangent line given fx. The slope of the tangent line at point P, x, y is m equals the limit. H is approaching to 0. F of x plus h minus f of x divided by h. This is our formula.